At the beginning of this year, I tasked you with building a boat and holding as many pennies as possible. Before we did so, we calculated the ideal volume, in other words, the largest volume for the amount of aluminum foil that I gave you. We then proceeded to build boats, which did fantastically, but all of them collapsed before they were able to reach their potential. They still floated in the water, but the material crushed. And so I decided to see if I could build that boat out of some material that wouldn't collapse on itself under the weight of the pennies and see just how well it would do. I was curious before we got to the actual testing if I could predict how many pennies that it would hold. And so I made a few measurements, did some few Google searches, and I want to share that with you before we get to it. So the idea behind floating a boat is when you displace water, you should be able to hold the amount of weight of the water that's displaced. So we need to know the volume of the boat. Volume of the boat turned out to be 5.5 by 21 by 20.9 centimeters for a total of, and I converted this to meters cubed because of the density of water, 0.00241395 meters cubed. I'm sure I was 100% accurate with that, by the way. Yeah. I looked up density of water and some massive pennies on Google, and my quick Google search turned out that it was 997 kilograms per meter cubed, which is why I use meters cubed here. Massive pennies was different for different years. Before 1982, they used a heavier material. They were 3.1 grams each, but at 1982, they changed the material, made them a little bit lighter as a result, and they were 2.5 grams. Now, I didn't really want to go through every single penny and calculate its weight. So I took a sample, did an average of the pennies in that sample. Turned out that they averaged 2.54 grams for the sample I took. So I'm going to assume that it would continue to have that same average. That may or may not be correct on this. All right, now we take this number, and if we multiply the density of the water by that, the 0.00241395, and I should convert this to grams, so we're in the same units. So that would be 997,000 grams per meter cube. That will tell me how many grams of water we've displaced with the boat. That ended up being 2,406.7 grams. The boat itself has some weight, so took a quick measurement. Turned out it was 126 grams. So that's going to weigh it down a little bit. Let's take away those 126 grams and we end up with 2,280.7 grams of water that we can displace. Assuming that this is the average, all we should have to do is divide that by the 2.54, and that gives us a total of 898 pennies. That is my prediction for the amount we hold. Let's go see how we did. Grand total of 833 pennies held in that boat. So we were a little bit off, 65 pennies off. Written as a percentage, that's about 7%. I can think of a couple of reasons why we might be off. The edge started leaking over a little bit. It's hard to get it perfectly level, so a little bit of water leaked in. It didn't appear that that would have been 65 pennies worth of water. So it could be that our measurements were a little bit off. It could be that I had some other factors, that maybe my boat weighed a little bit more than I had, and I was a little off on that. But I'm pretty pleased with how close we are overall. And in the 800s of pennies, nice, love it. Thank you guys.